Hello, everyone. Yeah, welcome back. We have another question to solve today, and the question we are solving today is right here on the board. And we are giving solve. Anytime you come across that word in any mathematical question and you are asked to solve, that means there is a particular letter in that question that they actually want you to get the value of. But if you look at this particular question, we have two different letters here. We have letter X, and we also have letter A. But if you notice, since the X is on the right hand side and at the same time on the left hand side, that means the X will cancel themselves out and we are not going to find the X. But if you look at this A, you will observe that A is only on the right hand side. So the A that is here now is actually what we need to find the value of. Now let's start off. We have here now, you should have something like this, m raised to power 2. M raised to power 2 means m times m. That is what we are going to have here. So here I am going to have log 9x times log 9x is now equal to log 3x times log ax. We have this. Where do we go from here? We need to simplify the base 9 that is here. Since we already know that 9 is equal to 3 times 3, which is the same thing as 3 raised to power 2. That means here I am going to have log 3 square to the power of x times log 3 square to the power of x. Everything is now equal to log 3 raised to power x times log a raised to power x. There is a certain law in indices whereby when you are dealing with the base and the base have, this is what I'm trying to say. If you have something like this, log m raised to power n, and you have p here, normally you can see that the base also have a power. The power of this base can actually become a coefficient, and when it becomes a coefficient, you are going to have 1 all over n log m raised power p, and that is exactly what you are going to have here. So here now I am going to have 1 all over 2 log 3x times 1 all over 2, the same thing we have here, log 3x is now equal to log 3x times log ax. So from here, the 1 over 2, we can multiply it together. That means I am going to have 1 all over 4. As in 1 over 2 times 1 over 2, they give us 1 all over 4. So I have here log 3x times log 3x is now equal to log 3x times log ax. From here, you will notice that log 3x is common to both sides. So I can divide the left hand side and the right hand side by log 3x. I will equally do the same thing here, log 3x. So if I should do that, what will happen? The log 3 we cancel. The log 3 we cancel. So we are now left with 1 all over 4 log 3x is now equal to log ax. Now, where do we go from here? We have something of this nature. There's a fraction here. I can actually make this 1 over 4. I can put over 4 here. I can put over 4 here. So I can also make this one too to be a fraction. Then I can now cross multiply. If I should cross multiply that, that means that we have this one we go, why this one we go to the other side. So we have log 3x is now equal to 4 log ax. And when you have something of this nature, the coefficient can also serve as a power. As if you have something like this, log a b raised to power n it is always equal. This one will serve as the coefficient. We have n log AB. So here we have log 3 raised to power x is now equal to log a raised to power x4. I have this. What can I do from here again? Or before I apply that, let's do it like this. Before I apply that, let's do it like this. The base here is 3. The base here is a. And the powers are x and x. We can actually make the power to become the base. If you make the power to become the base, that means you are talking about something of this nature. When you have log AB, it is the same thing as 1 all over log BA. That is exactly what we are going to do to both sides. If we should do that now, we are going to have 1 all over log S3 is equal to 4 all over log XA. So we are successfully change the base now to x. So from there now, we can now cross multiply. If I cross multiply, I will have something like this. I am going to have now log xa to multiply this one that is here. Then I will have this 4 to multiply the log s3. That means I will have here 4 log x3. So from here, I can now move what I want to do before. I can move this to the other side. That means I will have log x a is now equal to log x 3 raised to the power of 4. But if you observe very well, you will notice that log x is common to both sides. So the log x will cancel. That means we are now having a to be equal to 3 raised to power 4. And 3 raised to power 4 is of course 3 times 3 times 3 times 3. That means our a now will now be 3 times 3 times 3 times 3. And that is 9 times 9. So our a will be equal to 81. As you can see, solving questions of this nature involve the applications of the uses of the law of indices. We stop here for now and we take it up from here next time. Thank you for watching. God bless you.